tayo nagbabalik sa mga lessons natin. And then, yung lessons natin, mga lessons natin, 3 na lang yung natitira. Yung 2 hindi ko man nai-spoil. And then, dito muna tayo sa third to the last, no? Third to the last topic natin ngayong 4th grading period. At malapit na tayo matapos sa mga topics natin for grade 9. At yung topic natin for this time, which is all about the laws of thermodynamics, no? Then, gusto ko man i-spoil kung ano man yung ibig sabihin ng 2 image na nakikita nyo dyan with an up and down. Mamaya malalaman nyo rin siya kung ano-ano yung mga yan at kung saan sila kabilang dun sa mismong topic natin for this day. At total hindi naman tayo nagmamadali, pwede na tayo magsimula. Okay, so before tayo mag-start, no, I just want to tell, no, or ask each one of you, no, what happens whenever we use energy to do work, no? Just like for example, si Kuya, no, tinutulak niya yung isang kahon, no, papunta dun sa gusto niyang paglagyan, no. And then next naman, if you try to rub your hands briskly, what is produced, no? So alam na natin yun. Ayoko sabihin yung sagot, alam niyo na kung ano yung magiging result niyan, dahil alam ko karamihan sa atin ay ginagawa yan, lalo na pag malamig. And then, do you observe that heat is also produced every time you use your appliances at home? No? Ikaw na makakasagot niyan, kaibigan. And then, how about when you drive a car? No? Ano naman kaya nangyayari? Diba? Nakakaramdam ba tayo ng init or ng lamig? Depende, no? Lamig kung naka-aircon yung ating kotse or yung sa ating sasakyan. Pero usually, na-applyan din yan ng heat malamang, no? Lalo na sa kanyang engine na nandun sa loob. And then, dito sa dito sa image na ito, in the above observations, do you think there is a relationship between energy, mechanical work, and heat? So, let us find out kung ano man yun. And then, mag-proceed na tayo dito sa first topic natin, which is all about thermodynamics. So, which is the study of heat and its transformation to mechanical energy. It is coined from the Greek word meaning movement of heat. And then, because it was developed in the 1800s when the atomic and molecular nature of matter was yet to be understood, thermodynamics bypasses the microscopic and molecular details of systems. Rather, it focuses on the macroscopic or large-scale level mechanical work, pressure, temperature, and their roles in energy transformation. And then, in terms of their concepts, no, nandiyan yung thermal energy, heat, at saka temperature. No? So, yung thermal energy, it refers to the energy contained within a system that is responsible for its temperature, na nakakapaglikha ng heat, di ba, from the word itself, thermal. No? Then, malalaman natin mamaya kung ano yung system na tinutukoy natin. No? Sa lahat ng bagay, merong system, di ba? Then, heat is the flow of thermal energy, and then temperature at yung physical quantity that expresses hot and cold, which is measured with the use of thermometer. Like the other branches of physics, thermodynamics is also governed by laws which are restatements of the laws of conservation of energy. No? So, in terms of history of thermodynamics, ayan. So, in 1824, meron tayong French military engineer na itago natin sa pangalan sa Carnot. Actually, parang mahaba yata yung pangalan niya, pinaikli ko lang. Introduced the concept of the heat engine cycle and the principles of reversibility, both of which greatly influenced the development of the science of thermodynamics. And then Carnot's work concerned the limitation on the maximum amount of work that can be obtained from the steam engine operating with the high temperature heat transfer as its driving force. Malalaman natin siya sa second law. Ay, medyo na-spoil ko kayo. Sa second law of thermodynamics, no? And then next po, sumunod naman dito si Rudolf Clausius. Isa siyang German mathematician and physicist na nakapag-contribute ng concept of entropy at saka second law of thermodynamics. So sa second law, medyo na-spoil ko na kayo dito. It states that every process that occurs in nature is irreversible and unidirectional, with the direction being dictated by an overall increase in entropy. Together with the first law, it forms the basis of the science of classical thermodynamics. And then, sa history, in terms of their history, meron na formulate na 2 branches ng thermodynamics, no? So which are the classical thermodynamics, which focuses on the large scale level or macroscopic level of studying heat, and then statistical mechanics, no? And then sa thermodynamics, nakalink yung other branches para mapag-aralan yan, just like chemistry, engineering, and information theory, no? So ayun po. So, kapag sinabi natin classical thermodynamics, it is a field that attempts to express macroscopic thermodynamic properties in terms of the development of individual particles and their interactions. What about the statistical thermodynamics or statistical mechanics? No? It involves the consideration of individual atoms or molecules in microscopic view. And then, so ayan na po. Ayan po yung definition niya by itself. It speaks for this image itself. So, in terms of mechanisms ng thermal equilibrium, there is no net flow of heat between two objects. Two objects in thermal equilibrium have the same temperature, and we have a real example of thermal equilibrium na nakikita natin sa araw-araw. So, just like for example, measuring body temperature through the use of thermometer. Products that are sold natural may have passed through a refrigerator, and I think this is the last example, the permanence of the glaciers in the sea and at the poles is a particular case of thermal equilibrium. So, proceed tayo dito sa, actually, yung laws of thermodynamics, apat talaga siya. No? Una, Zeroth Law of Thermodynamics. Pangalawa is yung first law of thermodynamics. Next is second law. Pang-apat is third law of thermodynamics. Pero hindi naman important. Sa ngayon, hindi kasi importante yung dito, yung pang-apat o yung panghuli. Dapat nga nag-focus na tayo sa dalawang laws of thermodynamics, pero gusto kong isama ito kasi isa ito sa naging foundation ng pag-aaral ng thermodynamics, diba? So in Zeroth Law, it deals with the thermal equilibrium, which we describe a situation in which there is no net heat flow, no? So if two systems are in thermal equilibrium with a third system, then those two are in thermal equilibrium with each other, katulad na nakita nyo dito kanina. And then this may seem if two objects are at the same temperature, there will not be exhibits heat flow when they come into contact with one another. So tulad na nakikita ninyo dyan. So tulad na nakikita nyo, temperature is an indicator of thermal equilibrium. So if two objects are in thermal equilibrium with thermometers that treat the same temperature, the objects will be in thermal equilibrium with each other, which therefore allows us to gather all kinds of thermodynamic data in our laboratory. And then, ito na nga yung sinasabi ko, no? So, ano yung pinagkaiba ng systems at surroundings? Yung system, it is the collection of objects we are examining, no? Kung ano yung nasa loob na yun, ito yung nasa system, nasa loob. Then yung surroundings, nasa kapaligiran natin, or sa madaling sabi, it represents the nearby environment of a system. Ayan, madali lang naman. It speaks for itself. And then, ano yung pinagkaiba ng diathermal walls at saka adiabatic walls, since first time lang natin siya napakinggan. So, some systems allow heat to flow in and out, which is known as diathermal walls. No, nakakapasok yung heat. Then yung kapag adiabatic, hindi siya tinatablan or hindi nakakapasok yung heat doon. Ang tawag sa kanya is adiabatic walls. So, proceed na tayo sa first law of thermodynamics. So, sa first law of thermodynamics, a restatement of the law of energy conservation usually as it applies to systems involving changes in temperature. The heat added to a system equals an increase in internal energy plus external work done by the system. Then this law is expressed as delta U is equals to Q minus W. So ano ibig sabihin yan? Yung delta U, ito yung change sa internal energy. Yung Q, ito yung energy transferred as heat. And then yung W, it is the work done either by or on the system. Mag-iingat tayo dito pag meron tayong word problems, no? Para ma-identify natin yung value ng work, no? Meron tayong mga prerequisites na kailangan sundin, just like this. Reminder, Q is positive if the heat added to the system. Q is negative if heat leaves the system. Kapag sa Q, kapag positive, added. Kapag negative yun, wala siya sa system or yun nga, leave. And then yung W naman, masasabi natin positive ang work. W stands for work. No? Masasabi natin positive ang work is which is done by the system. And then negative naman ang work if it is done on the system. Tandaan natin yan. All of these are measured by joules. Joules po ang gagamitin nating unit since ang usapan pa rin natin dito ay energy. Ito na nga, nandito na tayo sa sample problem number 1. So, 3,000 joule of heat is added to a system and 2,500 joule of work is done by the system. So what is the change in internal energy of the system? So meron tayong given na heat, no? Positive 3,000 joule, and then yung work positive 2,500. 25 no? 2,500 joule. So yung required na hinahanap natin is yung internal energy or yung delta U. And then yung equation, yan. And then solution 3,000 joule minus 2,500 joule. Since parehas naman silang positive, so wala naman ng reason para balitan pa natin siya. Matik na yun. And then 3,000 minus 2,500. May hilig ako mag-2,500. Ano yun, pera? 2,500 is equals to 500 joules, which is the internal energy increases by 500 joules. Then last two, sample problem number 2, 2,000 joule of heat is added to a system and 2,500 joule of work is done on the system. What is the change in internal energy of the system? So meron tayong heat, no, na positive 2,000 joule, and then yung work natin is negative 2,500 joule. Bakit naging 2,000 negative 2,500? That because the work is negative if it is done on the system. Ayun na, may hint na tayo dun, no? Malalaman na natin. And then since nawawala yung internal energy at ganun yung equation na gagamitin natin, ang solution na gagawin natin is ito, delta U is equals to 2,000 joule minus negative 2,500, no? Or 2,500 joule. So magta-transform siya, instead of negative, magiging positive na magiging outcome niya. So ang magiging internal energy natin is 4,500 joules. So ang internal energy increases by 4,500 joules. And then last sample problem, 2,000 joule of heat leaves the system and 3,000 joule of work is done on the system. Ano yun yung kanilang internal energy ng system nila? Since yung heat is negative 2,000 joule, that because it leaves the system, and then yung work is done on, no? So automatically negative yung magiging answer na, yung magiging value niya. And then yung required is internal energy equation, same pa rin. So same process, same procedure pa rin. Negative 2,000 minus negative 3,000. So instead of that, magiging ganito yung magta-transform siya into this. So negative 2,000 plus 3,000 is equals to 1,000 joules. So dito na nga sa summary of the first law of thermodynamics. If heat is added to the system, then the internal energy of the system increases. If the heat leaves the system, then the internal energy of the system decreases. No? If the work is done by the system, then the internal energy of the system decreases, and if the work is done on the system, then the internal energy of the system increases. Then dito na tayo sa final topic natin, which is all about the second law of thermodynamics. So in terms of heat engine, consider the air in an airtight can which is heated on a stove. The air inside the can is considered the system. Since the can has a fixed volume, the air will not be able to do any work on the can. As the heat goes inside the can, it increases the internal energy of the enclosed air, which results to an just remember, heat will never spontaneously flow from a cold object to a hot object. Also, no machine can be completely efficient in converting energy to work. Some input energy is dissipated as heat, and finally, all systems tend to become more and more disordered, as time goes by. So, however, if this can is fitted with a movable piston, then the heated air in the can will do work when it expands and pushes the piston outward. This simple process forms the basics of a heat engine. So, a heat engine is any device that changes internal energy into mechanical work. There are varied types of heat engines, just like jet engines, internal combustion engines, and steam engines. Then the basic principles is the mechanical work that can be deduced only when heat flows from a high temperature region to a low temperature region. In such a system, there are two things involved, just like yung HTR or high temperature reservoir and low temperature reservoir, which is yung LTR. So mag-proceed na tayo sa engine cycle. So meron tayong Otto cycle, diesel engine cycle, and then Carnot cycle. So yung Otto cycle was originally designed by Alphonse de Rochas, correct me if I am wrong sa pronunciation. In 1876, a German engineer by the name of Nicholas Otto implemented his theory. This engine has 4 strokes called intake, compression, power, and exhaust. So ayan na po siya. Just tignan natin kung paano yung process ng first cycle stroke na gasoline engine na yan dito sa next slide. Kung sinabi nating intake, the piston descends with one of the open inlet valves, hence receiving combustible mixture. The movement of piston is downward and the mixture of gases filled inside the cylinder. In terms of compression, it moves upward and both valves are then closed and the gas is compressed adiabatically. It means hindi nakakapasok yung heat. The pressure and the temperature will both increases. In terms of power, it starts by the chemical reaction or a spark, which produces heat causing the pressure to increase at a constant volume. The piston will move downward and the mixture of gases will be ignited by the spark plug. In terms of exhaust, the piston ejects the burnt gas through an open inlet valve, so it is moving up and the mixture of gases will be expelled out by the exhaust pipe. So, ayan yung PV diagram ng or yung pressure volume diagram ng Otto cycle. So, medyo mahaba-haba lang to. Meron tayong 6 stages. So, in stage 1, the beginning of the intake stroke of the engine, the pressure is near atmospheric pressure and the gas volume is at a minimum. Between stage 1 and stage 2, the piston is pulled out of the cylinder with the intake valve open. The pressure remains constant and the gas volume increases as fuel or air mixture is drawn into the cylinder through the intake valve. And then stage 2, it begins the compression stroke of the engine with the closing of the intake valve. Between stage 2 and stage 3, the piston moves back into the cylinder, the gas volume decreases and the pressure increases because work is done with the gas by the piston. Stage 3 is the beginning of the combustion of the fuel or air mixture. The combustion occurs very quickly and the volume remains constant. Heat is released during combustion, which increases both the temperature and the pressure according to the equations of state. Yung equations of state, medyo malapit ito sa, hindi naman sa medyo, malapit siya sa mismong real gas law. At yun ano nyo naman siya, mapapag-aralan nyo o yung mismong ilan sa mga gas laws na pagdating nyo ng grade 10. So, stage 4 begins the power stroke of the engine. Then, between stage 4 and stage 5, the piston is driven towards the crankshaft pala. The volume increased and the pressure falls as work is done by the gas in the piston. Then, at stage 5, the exhaust valve is opened and the residual heat in the gas is exchanged with the surroundings. The volume remains constant and the pressure adjusts back to atmospheric conditions. And then, I think this is the last stage. Stage 6 begins the exhaust stroke of the engine during the piston moves back into the cylinder. The volume decreases and the pressure remains constant. At the end of the exhaust stroke, conditions have returned to stage 1 and the process repeats itself. So, yun na, tapos na tayo dun sa PV diagram cycle. PV diagram na yun. So, nandito na tayo sa diesel engine cycle na na-develop ni Rudolf Diesel, a French engineer. Unlike the Otto cycle, the diesel engine takes in air instead of combustion mixture. Also, its compression stroke happen at a greater rate than that of a petrol engine or Otto cycle. And then, the diesel internal combustion engine differs from the gasoline-powered Otto cycle by using a higher compression of the fuel to ignite the fuel rather than using a spark plug. Compression ignition rather than spark ignition. So, ayan siya. Ito yung mismong engine cycle, yung mismong diesel engine. Yung mismong piston. And then, I think this is the last part ng engine cycle, which is the Carnot Cycle. Noong 1820, si Nicholas Leonard Sade Carnot has already though of this problem about heat engines. He was very much concerned with the efficiency of the engines, that he visualized the heat engine as a kind of water wheel in which heat, which is the fluid, is dropped from a high temperature to a low temperature, losing potential energy. Carnot knew that the most efficient watt wheels were those that operated smoothly. So he meant that during the process, water goes into the buckets at the top from the same level, but it doesn't fall in any height. For the heat engine to be efficient, the heat should flow from the high temperature reservoir into the engine with no drop in temperature. Thus, as the heat is supplied and the gas expands, the temperature of the gas must stay the same as that of the heat reservoir. So, ayan na yung image mismong diagram ng Carnot engine in terms of their differences in hindi naman sa differences in relationship to the pressure and volume. So, however, sadly Carnot find out that his developed cycle is the most efficient engine. This cycle has no incidental wasteful processes such as friction and no conduction of heat between different parts of the engine at different temperature is observed. So, ito na nga siya, no? So, these are the specific regions which maintains their temperature even when heat is extracted or added to them. So, a hot reservoir at temperature of TH supplies heat to the heat engine. Part of this heat is converted to mechanical energy to do work, while some go to the cold reservoir at temperature, which means yung TC or yung cold reservoir. Heat is not completely converted to a useful work. Some heat is wasted. A heat engine is a machine that can only convert a portion of heat it has received from the source. Some dissipate due to the friction of heat engine parts, while some go to the cold reservoir as wasted and energy. The amount of heat converted to work determines the thermal efficiency ng heat engine. So, katulad ng equation na yan, no? So, since our input energy is just the heat coming from the hot reservoir and the work is just the difference between the heat from the reservoir and the heat going to the cold reservoir, we can express thermal efficiency just as shown in the equation above. No, but above, no, dapat below. Ano ba naman yan? Okay, so thermal efficiency can be 100% only if the output energy is zero. However, it is impossible to have a zero output because doing work always involves releases of heat, no? So, just like this, yung HH at HC. Yung HH, no? It stands for the input energy from hot reservoir, and then yung HC, ito yung output energy na nanggaling sa cold reservoir. So, in terms of ideal thermal efficiency, even ideal thermal efficiency cannot be 100% because it is impossible to lower the temperature to 0 Kelvin. Just like yung TH, ito yung temperature of the hot reservoir in Kelvin, and then yung TC, ito yung temperature for the cold reservoir in Kelvin. No? So, yun yung formula nila or yung equation nila. So, sample problem number 1, meron na tayong given na ano yung HH nga pala ulit. Balikan natin. So, yung HH na tinutukoy ko dito is hot reservoir, and then yung hot reservoir natin is 4,000 joule, and then yung 500 joule naman yung cold reservoir. Yung formula natin is, ayan, solution, 4,000 joule minus 500 joule. Minus muna natin yun. Ayan, and then i-divide natin sa 4,000 joule. Nagkamali ako ng ano. I'm sorry about this. We will change. Ayan, no? Yan, napalitan na natin. So, ayan na nga siya, no? Na-divide na natin yung 3,500 sa 4,000. So, ang lumabas is 0.875 times 100 para magkaroon tayo ng percentage. So, yung thermal efficiency niya is 87.5%. So, second to the last, no? Sample problem number 2, yung hot reservoir natin is 500 Kelvin, and then 250 Kelvin naman yung cold reservoir. Yung formula natin, yung solution natin, 500K minus 250K. And then, ayan, 250K divided by 500K. Ayan, no? Ayan. And then, 0.5 Kelvin, multiply natin sa 100, is, ang ating thermal efficiency is 50%. What about this, no? So, ang naging given natin is, meron tayong Celsius, pero, ang hinahanap natin ditong unit for temperature is Kelvin. So, kailangan natin itong i-transform from Celsius, i-convert natin siya into Kelvin. So, 85 degrees Celsius plus 273 is equals to 358 Kelvin as a hot thermal, ano ba yung tawag dito? I forgot about this. Yung TH. Yung TH, hindi po yung tamang hinala, iba po yun. Hot reservoir temperature, no? And then, yun yung kanyang TH, no, 358 Kelvin, and then yung cold reservoir temperature 65 degrees Celsius plus 273 is equals to 338 Kelvin. So yung formula, ganyan na yung gagamitin natin based po dun sa pinakita ko kanina. So yung solution natin, pagdating dito, ire-recta na natin kaagad. No? So recta, compute na kaagad dito sa part na ito. 1 minus 338 divided by 358 na kaagad. Ganun lang kasimple. So 0.05 times 100 is equals to yung kanyang thermal efficiency is 5.6%, or kung gusto natin itong i-round, kung gugustuhin man natin i-round off, pero ang rule natin dito, kung ano yung dapat na i-round off, please i-round off nyo na. Ayan, 6%. So lastly, machines are never 100% efficient because only a portion of energy is converted to useful work, while some energy is wasted as it goes to the cold reservoir or as it dissipates due to the friction of the parts of the machine. Moreover, doing work always involves the release of heat. It is also impossible to lower the temperature of the cold reservoir to 0 Kelvin. So ayun lamang po, no? So dito na po nagtatapos yung ating lesson, at may mga gusto pa ba akong sabihin? Yun lang naman po, no? So dito na po nagtatapos yung ating lesson. Kung may mga clarifications or questions, clarifications or concerns, please leave a comment below, and then that's all for today. Goodbye. See you sa susunod nating mga lessons pa.